How long is now? Everyone thinks they know the answer. You wake up now, you drink your coffee now, you hear these words now. The past is gone, the future hasn't arrived yet, and your life unfolds on a thin line separating the two. It feels obvious enough that almost nobody questions it. Now doesn't feel like an idea. It feels like a property of reality itself, something the entire universe shares with you. Yesterday exists, tomorrow exists, and somewhere between them there is now. The strange part isn't that this picture is incomplete. The strange part is that science has trouble finding this anywhere, not in the brain, not in physics. The closer you look, the harder it becomes to identify the present moment you assume you've been living inside your entire life. Start with something simple. A glass falls from a table. You see it happen, and it feels immediate. But nothing about that experience is immediate. Light reflected from the glass enters your eyes. Photoreceptors in the retina convert photons into electrical signals. Those signals travel through retinal circuits, along the optic nerve, through the thalamus, and eventually into the visual cortex. Sound follows a different route. Vibrations move the eardrum, and hair cells inside the cochlea transform those vibrations into neural activity. The signals pass through structures in the brainstem before reaching the auditory cortex. Touch uses different receptors and different pathways. Each sensory system operates at its own speed. Reality reaches your brain in separate pieces that do not arrive together. If consciousness simply displayed information the moment it arrived, your experience would constantly fall apart. The sound of the glass would separate from the image of the glass. Touch would drift behind vision. The world would never quite line up. But that isn't what happens, because the brain delays its decision about what is happening before presenting you with something that feels whole. It gathers information across brief intervals before constructing what feels like a single moment. Neuroscientists call this temporal integration. There isn't one exact number that everyone agrees on, because different tasks require different timescales. But many experiments suggest that conscious experience is assembled over windows lasting tens to hundreds of milliseconds. Events occurring within roughly 100 milliseconds can be merged into one perceived present. The important detail is easy to miss. You do not consciously experience the world exactly as it happens. Your brain waits, it samples, it compares, and only then does it give you a coherent version of events. By the time you become aware of the present, that present is already slightly old. The moment you thought you were experiencing in real time has already been processed, organized, and reconstructed. And the brain isn't only reconstructing the recent past, it is also predicting the immediate future. Under predictive processing frameworks, perception is understood as a negotiation between incoming sensory information and internally generated expectations. Your nervous system continuously anticipates where a moving object will appear next, how another person's sentence is likely to end, and where your body should be during the next step. Waiting for complete certainty would take too long. Neural processing requires time, and organisms that reacted only after perfect information arrived would respond too slowly to survive. Prediction reduces delay. Perception becomes less like recording reality and more like controlled guessing, constrained by sensory evidence and constantly updated whenever the world refuses to match expectations. The present moment is not simply detected. It is assembled from memory, prediction, and correction. What feels immediate is actually the product of countless hidden processes operating beneath awareness. The version of reality you experience isn't delivered all at once. It is constructed, refined, and stabilized quickly enough to help you navigate a world that never pauses long enough for certainty. Then physics removes what remains of our intuition. In everyday life, we assume everyone shares the same now. A conversation happening here and a lightning strike somewhere else either happen simultaneously or they don't. It feels straightforward, almost self-evident. But according to Einstein's special theory of relativity, it isn't. Simultaneity depends on the observer. Two events that occur at the same time for one observer may occur at different times for another, moving relative to the first. This isn't a measurement error, and it isn't an illusion. It emerges from the structure of space-time itself. Because the speed of light remains constant for all observers, There is no universal clock keeping the same time everywhere in the universe, no shared reference frame that defines a single now. Which brings us back to the original question, how long is now? If you're asking about human experience, neuroscience gives a surprisingly concrete answer. The present moment you consciously experience appears to span roughly 1/10 to a few tenths of a second, around 100 to 300 milliseconds. During that interval, sensory signals arrive, predictions are tested, and information is merged into something stable enough for action. Your experience now is not infinitely thin. It has duration. It is a working buffer, a biological compromise between speed and accuracy. But if you're asking about the universe itself, the answer changes completely. Physics offers no evidence for a cosmic present shared by everything that exists. There is no master clock announcing the same now across space-time. That division belongs to us, not to reality. After all this time, the closest answer we have is also the least satisfying. The present is neither an illusion nor a fundamental feature of reality. It's a tool, a solution built by nervous systems trying to function in a world where information always arrives a little too late.